we have integral of rational function. Because we have denominator already factorized, so we can rewrite our rational function. Let me do this. We have 9x to 4th power minus 3x cubed minus 23x squared plus 30x minus 1 over x minus 1 to 4th power times x plus 3. Because we have repeated linear factor x minus 1, so we need to put first x minus 1 to 4th power, because x is in first power, so we have in numerator only a, plus, now will be x minus 1 to 3rd power, 1 less, because we have to 4 now is to 3rd power, and x is in first power still, so we have only b, plus, next will be x minus 1 to 2nd power, c, plus, we will have d over x minus 1. Next, we finish with x minus 1 to 4th power. We have only x plus 3, so we have to add plus. Denominator is x plus 3, and because x is still in first power, so we have only constant. In numerator we can put e. So now we will multiply both sides of our equation by denominator x minus 1 to 4th power times x plus 3 to reduce these fractions. So we will have on the left side only 9x to 4th power minus 3x to cube minus 23x squared plus 30x minus 1. And on the right side we will have, let me put this whole expression, we have times every fraction we have to multiply by x minus 4 to 4th power times x plus 3. So when we multiply first fraction by this, x minus 4 to 4, of course we have x minus 1. So x minus 1 to 4th power we will reduce, and we will have only a times x plus 3. Plus, next we have to do the same with the second fraction. We multiply by x minus 1 to 4th power. So we will have b times x minus 1 only, and we have x plus 3. Plus, now we have third fraction, so will be c times x minus 1 square only times x plus 3 plus d times x minus 1 to 3rd power times x plus 3, and plus we have e over x plus 3 times this expression, so x plus 3 will reduce and we will have only plus e times x minus 1 to 4th power. So now we need to find this constant a, b, c, d, and e. First, we can do substitution to find some of these constants, because for x equals negative 3, we will have negative 3 plus 3, so this expression will reduce, and this, and this, and that. So only left e times will be negative 3 minus 1 to 4th power. So let me start from the beginning. Left side will be equal 9 times negative 3 to 4th power minus 3 times negative 3 to 3rd minus 23 negative 3 square plus 30 times negative 3 minus 1. So this is equal, we can use calculator, and we have 9 times negative 3 to 4th power minus 3 times negative 3 to third power minus 23 times negative 3 to second power plus 30 times negative 3 minus 1. This is equal 512. And right side, like I said, we will have only e times negative 3, we substitute x by negative 3, minus 1 to fourth power. So this is equal e times negative 4 to fourth power. This is equal to 56 e. Left side must be equal to right side. So we have 256 e must be equal 512. Now we divide both sides by 256. So we have that e is equal to. Next, we can do substitution. For x, we will put 1. Why? Because for x equals 1, our second expression will be 0, because we will have 1 minus 1 will be 0. 0 times whatever will be 0. Next expression with c will reduce, and d and e. Only expression with a stay. So let's start from the beginning. We have L, left side is equal 9 times 1 to fourth power minus 3 times 1 to third power minus 23 times 1 square plus 30 times 1 minus 1. This is equal. We can use calculator one more time. When we put 1 to fourth power or to third or to second, still will be 1. So we need to put 9 minus 3 minus 23 plus 30 minus 1. So this is equal 12. And on the right side, like I said, we will have only a times 1 plus 3. I substitute x by 1. So this is equal 4a. Left side must be equal to right side. So we have 4a is equal 12. We divide both sides by 4. So we have that a is equal 3. We have e and a. We need to find b, c, and d. So next step, we have to compare coefficients before x to fourth power on both sides. So first we need to do this multiplication. The left side we will rewrite, and we have 9x to fourth power minus 3x cube minus 23x squared plus 30x minus 1. So this is equal. We can substitute a by 3. So we have 3 times x plus 3, and we have plus. And we can do first multiplication, x minus 1 times x plus 3. So it will be x squared plus 3x minus x, so will be plus 2x and minus 3 plus, and first I will multiply c times x plus 3, and I will take x minus 1 to second power. So first x minus 1 to second power is x squared minus 2x plus 1, and will be times cx plus 3 plus. Now we have x minus 1 to third power. So we need to use formula that when we have a minus b cube, this is equal a cube minus 3a squared b plus 3ab squared minus b cube. This formula we will use to find x minus 1 cube. to cube power. And we will multiply d times x plus 3. So we will have in first parenthesis dx plus 3d, and in the second we will have x cube minus 3x square plus 3x minus 1. I just used this formula. And we have plus, we have x minus 1 to fourth power. So we can rewrite this, that this is x minus 1 square times x minus 1 square. So first I will put x minus 1 square, so it's x square minus 2x plus 1, and will be x square minus 2x plus 1 times e, and we know that e is equal to. So now we have to copy left side. We have 9x to fourth power minus 3x cube minus 23x square plus 30x minus 1. So this is equal to, we have 3x plus 9 plus bx square plus 2bx minus 3b, and next we have plus, will be cx cube plus 3cx square minus 2cx square minus 6cx plus cx plus 3c, and we have dx times x cubed, so is dx to fourth power minus 3dx to third power plus 3dx square minus dx, and now we will multiply by 3d every expression in this parenthesis. So we have 3 plus, of course, 3d x cube minus 9d x square plus 9x d minus d, and now we have to multiply x square by x square, so it's x to fourth power times 2 we have, so it will be 2x to fourth power. Next we have negative 2x cube, and we have times 2. Next we have plus x square times 2, so will be 2x square, and now we have negative 2x cube times 2, positive will be 4x square, so times 2, so will be 8x square, and we have negative 2x times 1 and times 2, so negative 4x. Next we have 1 times x square and times 2, so will be plus 2x square, and we have minus 4x plus 2. So we can copy the left side. We have 9x to fourth power minus 3x cube minus 23x square plus 30x minus 1. This is equal. And on the right side we will combine the like terms, coefficient, first with coefficient x to fourth power expression. So we have dx to fourth power only and 2x to fourth power. So we have d x to fourth power and 2x to fourth power, so it will be d plus 2. Next we will put x cubed, so we have c, and we have negative 3d, and we have positive 3d. So this expression we can write, I will put this plus 3d, and next we have 4x cubed and 4x cubed, so will be negative 8x cubed, and that's it. We can close brackets. Next we will combine the like terms with x squared. So we have plus x squared, and in parentheses we will have b. Next we have plus 3c minus 2c. Next we have plus d, 3d of course, and we have negative 9d, and we have 2x squared and 8x squared, so it's 10 plus 2, so it's 12 plus 12. And plus, we don't have to do this because we found E and A, so now it's enough if we compare coefficient before x to fourth power, x to third power, and x squared to find B, C, E, and D. So now we will compare coefficient before x to fourth power. On the left side we have 9. This should be equal to d plus 2. So we have that d is equal 7. Next, we have coefficient before x cubed. So this is equal 3d minus 3 plus 3d will reduce. And we will have, on the left side, we have negative 3, should be equal to c minus 8. So we have that c is equal 5. And coefficient before x squared now, we have negative 23. So this is equal, and we have on the right side b, 3c minus 2c will be plus c, and next we have 3d minus 9d, so this is negative 6d plus 12. We have 23 is equal b plus c is 5 minus 6 times d is 7 plus 12. So we can write that b is equal, we will have negative 23 minus 5 plus 6 times 7 is 42 minus 12. So we have that b is equal to. Now we can substitute a, b, c, d, and e, and we can rewrite our rational expression to sum of partial fractions. So let me copy. So our integral will be equal. We have a over x minus 1 to fourth power. So we found that a is equal 3 over will be x minus 1 to fourth power plus b is equal to, so we have 2 over x minus 1 to third power. Next we have plus c is equal 5, so we have 5 over x minus 1 to second power. Next we have plus d is equal 7 over x minus 1, and we have e is equal to over x plus 3. We have integral with respect to x. So this is equal. Now we can rewrite integral of sum to sum of integrals. So this is equal integral of 3 we can put before integral, so will be 3, and we will have 1 over x minus to fourth power plus, and with respect of course to x, and we have now 2 integral of 1 over x minus 1 to third power with respect to x plus 5 integral of 1 over x minus 1 to second power plus 7 integral of 1 over x minus 1 with respect to x, of course we have to add, and we have plus 2 integral of 1 over x plus 3 with respect to x. So this is equal. We will change this expression to power form because we have x minus 1 in denominator, so I will rewrite this that this is x minus 1 to power negative 4 with respect to x plus 2 times x minus 1 to negative third power with respect to x plus 5 times x minus 1 to, of course, integral to negative 2 power dx plus 7, and we have now integral 1 over x minus 1 to first power. In numerator we have derivative of the numerator, so we can write that this is equal natural logarithm of absolute value of x minus 1 plus constant we will write at the end plus 2, and the same situation is in the last integral, so this is natural logarithm of the absolute value of x plus 3 plus constant c we can write. Now we have to use integral of power function formula. We will copy 3 and we will have x minus 1 to power negative 4 plus 1 is negative 3 over negative 3 plus we have 2 and will be x minus 1 to power negative 3 plus 1 is negative 2 over negative 2 plus 5, and we have x to minus 1 to power negative 1 will be over negative 1, and the rest we have to rewrite natural logarithm of absolute value of x minus 1 plus 2 natural logarithm of absolute value of x plus 3 plus constant c. So 3 and 3 we can reduce, 2 and 2, so we have negative, we can write 1 over x minus 1 to third power, and positive and negative will be negative again, 1 over x minus 1 to second power because we have negative exponent, and positive and negative will be negative 5 over x minus 1 will be because we have negative exponent 1, and the rest we have to rewrite 7 natural logarithm of absolute value of x minus 1 plus 2 natural logarithm of absolute value of x plus 3 plus constant c. This is my solution.